Hey friends, welcome to the YouTube channel All About Electronics. So in this video, we will discuss the Z parameter of the two-port network. So in the previous video, we had seen that for the two-port network there are four variables. That is V1 and I1 for the port 1, while the V2 and I2 for the second port. And out of the four variables, the two variables are the independent variables, while the remaining two are the dependent variables. So for the Z parameter, the I1 and I2 are the independent variables, while the V1 and V2 are the dependent variables. That means V1 and V2 are the function of I1 and I2, and they can be expressed in terms of the I1 and I2. Now, as I said in the previous video, the two-port network contains only linear elements. That means the relation of this V1 and V2 with I1 and I2 is also linear. So for the Z parameter, the V1 can be expressed as Z11 times I1 plus Z12 times I2. Similarly, the V2 can be expressed as Z21 times I1 plus Z22 times I2, where this Z11, Z12, Z21 and Z22 are the proportionality constants and they are known as the Z parameters. Now these two expressions can also be expressed in terms of the matrix form. That means V1 and V2 is equal to the matrix of these Z parameters multiplied by I1 I2, or simply they can be represented as V is equal to Zi, where this V is the matrix of the dependent variables, while I is the matrix of the independent variables, and this Z is the matrix of these Z parameters. So now let us see how we can find the individual Z parameters. So the individual Z parameters can be found by setting one of the port currents to 0. So first of all, let us make this port current I2 as 0. That means the port 2 is the open circuited. So in this condition, this first expression can be written as V1 is equal to Z11 times I1, or we can say that Z11 is equal to V1 divided by I1 when this current I2 is equal to 0. Now if you see the unit of this parameter, then it has a unit of impedance, and in fact that is why it is represented by the symbol Z. So here in the numerator, the voltage is on the port 1 side, while in the denominator also the current is on the port 1 side, and in fact that is why the subscript is 11. Also, while finding this parameter, the port 2 is an open circuit. So this parameter is known as the open circuit driving point impedance, or simply the input impedance of the port 1 when the port 2 is open circuited. Similarly, when current I2 is equal to 0, then from the second expression we can write Z21 is equal to V2 divided by I1, and at that time this current I2 is equal to 0. So here the voltage in the numerator is on the output side or from the port 2 side, while the current on the denominator is on the port 1 side. So this parameter is known as the open circuit forward transfer impedance, because it relates the voltage on the output side with the current on the input side. Similarly, when the port 1 is open, or when current I1 is equal to 0, then from the first expression we can write Z12 is equal to V1 divided by I2, and at that time this current I1 is equal to 0. So this parameter relates the input voltage with the output current when the port 1 is open circuited. So this parameter is known as the open circuit reverse transfer impedance. And likewise, with current I1 is equal to 0, from the second expression we can write Z22 is equal to V2 divided by I2 when this current I1 is equal to 0. So this parameter relates the output voltage with the output current when the port 1 is open circuited. So it is known as the open circuit driving point impedance, or simply it is known as the output impedance of the two-port network when the port 1 is open circuited. And here is the representation of all 4 parameters. So as you can see, all the parameters have the unit of impedance, and all these parameters are measured when either input or output port is open circuited. So because of that, these Z parameters are also known as the open circuit impedance parameter. So now let us see the equivalent circuit of the two-port network in terms of these Z parameters. So we can write this first expression as V1 minus Z11 times I1 minus Z12 times I2, that is equal to 0. Similarly, we can write this second expression as V2 minus Z21 times I1 minus Z22 times I2, that is equal to 0. So this first expression represents the KVL equation for the equivalent circuit. So in the first expression, the V1 is the voltage on the input side, while this Z11 times I1 is the voltage drop across this impedance Z11. And if you see the third term, then there is a current I2. That means it represents the dependent source. And to be precise, it is the current controlled voltage source whose voltage depends on this current I2. Similarly, in the second expression, the voltage V2 is the voltage on the output port, while this term, that is Z22I2, is the voltage drop across the impedance Z22. And this Z21I1 is the current controlled voltage source. So this is the equivalent circuit of the two-port network in terms of the Z parameters. Now there are certain properties of the two-port network which frequently also occurs in the practical networks. And using these properties, the network can be analyzed quite easily. And these properties are the reciprocity and the symmetry of the network. So first of all, let us see what is reciprocal network. So let's say we have applied the supply voltage Vs on the port 1 and we are measuring the short circuit current at the port 2. Now if the network is reciprocal, then we should get the same short circuit current at the port 1 when we apply the supply voltage Vs at the port 2. Or in other words, a network is said to be a reciprocal if the ratio of excitation at one port to the response at other port is same if the excitation and the response are interchanged. So the two-port network is said to be a reciprocal if Z12 is equal to Z21. So if we know the Z parameters of any network, and if this condition gets satisfied, then we can say that the given two-port network is the reciprocal network. So now let us prove this condition. So let's say we have applied the supply voltage Vs at the port 1 and we are measuring the short circuit current at the port 2. That means here this voltage V1 is equal to Vs while the current I2 is equal to minus I2 dash. And here as the port 2 is the short circuited, so the voltage V2 is equal to 0. So from this we can write voltage Vs is equal to Z11 times I1 minus Z12 times I2 dash. Similarly, we can write the second expression as 0 is equal to Z21 times I1 minus Z22 times I2 dash. Now here we are interested in finding the ratio of Vs and the I2 dash. That means the ratio of the excitation to the response. So for that, let us find the value of I1 in terms of the I2 dash. That means from the second expression, we can say that the current I1 is equal to Z22 divided by Z21 times I2 dash. And if you put the value of I1 in first expression, then we can say that voltage Vs is equal to Z11 times Z22 divided by Z21 times I2 dash minus Z12 times I2 dash. Or we can say that voltage Vs is equal to I2 dash times Z11 times Z22 minus Z12 times Z21 divided by Z21. That means the ratio of Vs and the I2 dash is equal to Z11 times Z22 minus Z12 times Z21 divided by Z21. And let's say this is the equation number 1. Similarly, now let us say the voltage is applied at the port 2 and we are measuring the short circuit current at the port 1. So in this condition, the voltage V2 is equal to Vs while current I1 is equal to minus I1 dash. And here as the port 1 is short circuited, so voltage V1 is equal to 0. So let us put all these values in these two expressions. That means we can say that 0 is equal to minus Z11 times I1 dash plus Z12 times I2. And for the second expression, we can say that Vs is equal to minus Z21 times I1 dash plus Z22 times I2. Now once again, here we are interested in finding the ratio of this voltage Vs and the I1 dash. That is the ratio of the excitation to the response. So for that, let us find the value of current I2 in terms of the I1 dash. So from the first expression, we can say that current I2 is equal to Z11 divided by Z12 times I1 dash. And if we put the value of current I2 in the second expression, then we can write voltage Vs is equal to minus Z21 times I1 dash plus Z22 times Z11 divided by Z12 times I1 dash. Or we can say that voltage Vs is equal to I1 dash times Z22 times Z11 minus Z12 times Z21 divided by Z12. That means the ratio of voltage Vs and the I1 dash is equal to Z22 times Z11 minus Z12 times Z21 divided by Z12. And let's say this is the expression number 2. So if the two-port network is reciprocal, then these two ratios or the equation 1 and 2 should be equal. That means we can say that this Z21 should be equal to Z12. That means if this condition gets satisfied, then we can say that the network is a reciprocal network. Similarly, now let us see the condition for the symmetrical network. And for that, first of all, let us understand what is symmetrical network. So a two-port network is said to be a symmetrical network if the ratio of voltage to the current at one port is same as the ratio of voltage to the current at the other port with one of the port is open circuited. That means the ratio of V1 and I1 with I2 is equal to 0 is same as the V2 divided by I2 with I1 is equal to 0, then we can say that the two-port network is the symmetrical network. Or in other words, when the input impedance is same as the output impedance, then we can say that the two-port network is the symmetrical network. So now let us find the condition for the symmetry in terms of the Z parameters. So first of all, to find the ratio of this V1 and I1, let us assume that this current I2 is equal to 0 or the port 2 is the open circuited. So from the first expression we can write V1 divided by I1 with current I2 is equal to 0 is equal to Z11. And similarly, to find the ratio of voltage V2 and I2, let us assume that the current I1 is equal to 0 or the port 1 is open circuited. So in this condition, when I1 is equal to 0, then the ratio of V2 and I2 is equal to Z22. And for the symmetrical network, these two ratios should be equal. That means we can say that Z11 should be equal to Z22. So with the given Z parameters, if this condition gets satisfied, then we can say that the network is the symmetric network. So in this way, for the given two-port network, if we know the values of Z parameters, then we can easily check the condition of the symmetry and the reciprocity. So this is all about the Z parameters. And in the next video, we will solve some problems based on the Z parameter. But I hope in this video you understood how to find the Z parameters for the two-port network. So if you have any question or suggestion, do let me know here in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.